Okay, we're given square ABCD of side 1 cm and we're asked to find the area of this shaded part. Okay, the easiest way to solve this is to subtract the area of this part, that's this part, from that of the square. And if we can get the area of one, if you notice, we have 4 congruent areas. 1, 2, that I'm talking about C, B, G, H, A, B, D, H, C, and finally D, C, F. So once we subtract this area from the square, what is left is what we are asked to find. Okay, maybe let me shade it. So if we remove this area, if you notice this and that the same. If we remove this area, and finally if we remove this area, from the square, so that's what we are. And I'm going to solve it fast, but I will prove the formula I will use now. So if we call the area here if we call it A, okay, maybe let me. If we call it A, the area, this, they are the same, also the same, and also the same. So do you see it? We have 4 areas that are the same. So if you know the area of one, so I'm going to prove that the area here is equal to a squared over 12 times 3 root 3 minus pi. I'm going to prove it where a is the side of the square. I'm going to prove it. So we have 4 of them. Therefore, the area we are looking for, which is this B, area shaded, is now equal to area of the square, which is a squared, minus 4 of this, as you can see, C, B, G, B, A, H, A, D, E, and finally D, C, F. Do you see it? So minus 4 times a squared over 12 times 3 root 3 minus pi. So we can see that it is equal to a squared 4 minus 4 times, so we have minus root 3 a squared plus pi over 3 a squared. Yes, if you open up this, that's what you will be like, minus times minus plus. So 4, 3. So that 3, see it down here. Why the 3 here? We are left with only root 3. So do you see it? And they told us the side of this square is 1. Our area is now 1 minus root 3 plus pi over 3. So which is option A? So that's the answer. Option A. So let me now prove how I got this formula, because that's the major thing here. Once we know it, we've understood how I solved this. So let's move to the next diagram. Whereas ABC is a square, what is the area of the shaded region? So the first thing I have to do is to join some parts. So let's join D, K, and C. Let's join. So we've joined D to K and C to K. And if you notice, this is like a quarter circle. As DAC is a sector. That's a quarter circle. Now also, this is also a sector, a quarter circle. This is a square, so the angle, interior angle is, each is 90. And again, you can see that from here to here is also A. Yes, that's like the radius of this quarter circle. And if you look at this quarter circle BCD, you also see that here is also A. So this is the radius. And we also have A here, making each of these interior angles to be 60, because this is an equilateral triangle. Remember, since this is a square, means that the remaining angle here must be 30 degrees, so that it will sum to 90. So from this, you can see that this area of this shaded region, maybe let's call it A, is equal to the area of the sector minus the area of this segment. So let's call it A1, this is 8. So if you subtract A2 from the area of the sector CBK, that's what we are looking for. This is a segment. So for us to get is the area of this sector DKC minus area of the triangle. So that's it. So from here we can see that the area shaded is equal to area of sector CBK minus A2. Yes, once you subtract A2 from A1, that's where it is. But A2 is equal to area of sector DKC minus area of triangle DKC. Let's get this. This is equal to sector. We have 60 over 360 times pi a squared. That's area of a sector minus area of the triangle. This is an equilateral triangle. Have a special formula which is √3 over 4 sides square, and the side is A. So area of equilateral triangle is always √3 over 4 times the side squared. So we now substitute it. Therefore, the area shaded is equal to area of sector CBK. So we have 30 over 360 times pi a squared minus A2, which is this, which is 60 over 360 times pi a squared minus √3 over 4 a squared. So as you can see, minus times this is √3 over 4 a squared. I'm solving from the back because I want to subtract this from this. So this times this is this. So 30 over 360 is 1 over 12. While 60 over 360 is 1 over 6. 1 over 12 minus 1 over 6 is minus 1 over 12. So pi a squared. Which is the same as, we can find the LCM. The LCM is 12. And this in this 3, so 3 root 3. Why this in this is 1 minus pi. So what is common in both is a squared. A squared is common, you bring it out. 12 in this times that, you get this 12.